Greetings and welcome, friends. Mr. Waddy here. Today we're talking about section 7.2, multiplying polynomials today. It says multiplying binomials up here. I realize we're going to go beyond just binomials, my friends. So previously we've been adding polynomials, right? And when we added polynomials, you had to know the idea that, right, x plus, say, 2x, the way you do that was you add the coefficients, the 1 plus the 2 was 3, and they remain as x's. Now with multiplying, if I have x times x, right, I actually add their exponents. X times x, that's x to the 1 plus 1 is 2. And I would multiply their coefficients if I had them. So if this was like 2x times 1x, it would have been 2x squared sort of thing. And actually, just to make it a little bit more interesting, if I have x squared times x cubed, what do you think that would be? You would just simply add their exponents. I wrote this middle step in case that helps, so if you're adding that to your notes, you would have it. So the idea is for adding variables, you find like terms, right? And then you add their coefficients. For multiplying variables, if they're the same base, then you add their exponents. All right, so that's kind of like two things that you're going to have to be aware of, prerequisite skills to do this. So it says multiplying polynomials. The product of two polynomials is always a polynomial. All right, that's good to know. So it's going to give me something like itself. So like the set of integers, the set of polynomials is, remember this word, closed under multiplication. So when I multiply polynomials, I get more polynomials. That's what the idea of closed was. You can use the distributive property to multiply two binomials. So watch this. Here's example 1, part A. And I'm going to use a couple different colors here, colors. And what I'm going to do is, if I've got two things that are being multiplied by two things, so a binomial by a binomial, I'll take the first term here and I'm going to multiply it by each of those. So this is like, instead of everybody gets pi, like you were saying with the distributive property, it's like you're going around and passing out pies and sodas, and everyone gets a piece of pie and everyone gets a soda. All right? So the first thing I'm going to do, x times x is x squared, right? That's what I said a moment ago. So x times x is x squared. I will in a moment, so I'm not done yet. I'm not done yet. Good call, though. And let's see, x times 5 is 5x. No, 5x, because this 5 didn't have an x. So it's just 5x's, right? And now, like Kayla mentioned, well, what about this 2? And we distribute that as well. And it's up to you if you want to distribute and draw little arrows underneath, or you could draw them over. It doesn't matter. But this is a positive 2, so I'll multiply that. Positive 2 times x is plus 2x. And positive 2 times 5 is 10. And so now I've multiplied it. And now I've got to go through and combine like terms. Here, wait till everyone else catches up. All right, so x squared, there were no other squared, so x squared stays by itself. Let's see, 5x plus 2x, those are like terms because they have the same variable and exponents. And I just simply add their coefficients. 5 plus 2 is 7, and those are x's still. And then just plain old 10. All right, and this time I guess I'll have to use the yellow just because I'm running out of colors here. And so this is my answer when I multiply those two binomials. So we've multiplied, or we've used the distributive property before, but we've only passed out one thing at a time. This time, like I said, we're passing out two separate things. So let's do this quicker for this next one. So let's distribute this x to everybody in the parentheses. So x times x is x squared. And x times negative 4 will be negative 4x. And now, hey, I've also got to pass out this delicious 3 for everyone to enjoy. So multiply by 3. So 3 times x is plus 3x. And 3 times negative 4, negative 12. Yeah. Positive times a negative is a negative. And now once I'm done multiplying, I want to combine like terms like we did in the previous lesson. So x squared, there were no other x squareds. For x to the firsts, looks like I've got a couple that I should combine. So yeah, 3 times negative 4 became the negative 12 there, yeah. See, negative 4x plus 3x, how many x's is that? Negative 1 of them, right? That would have been like if I had 4 red rectangles and 3 green rectangles. 3's would cancel out, and I'd be left with 1 red rectangle left. And then the negative 12 had no constants to combine. All right, so the distributive property, all we're doing is we're taking the multiple things and distributing them to everybody in the second set of parentheses. All right. Well, let's see. I'll give you some more to look at here, and it doesn't just have to be in terms of x's. All right. You also could have other variables like y's and z's. How creative of these mathematicians. Let's see. Y being multiplied by both of those. What do you think y times y is? Yeah. And y times 1 would just be plus y. 1y, you know. And then, oh, I've got a 4 that I need to give everybody as well. Here we go. 4 times y is plus 4y. And then 4 times 1. Oh, 4. Yeah. And then if you have any like terms to combine, then you combine them. So y squared. Okay, where's what step are you? Which part? This y? All right, so y times y is y squared. You add the exponents. And so this y had a little invisible exponent of 1. That y had a little invisible exponent of 1. And y times y is y squared. And think about, right, squaring something literally meant multiplying it by itself. Just like if I had, right, 3 times 3 is 3 squared, which is 9. Right, y times y would be y squared. And I can't simplify that any further. So, right, multiplying something by itself is what squaring means. And so you'll just have to remember that. When I multiply a variable by itself, its exponent, I'll just add the exponents. And let's see, so y squared didn't have any other squared terms to combine. Then I've got 1y plus 4y. How many y's did I end up with? Yep. And then that 4, I didn't have any constants to combine with it, so it's just plus 4. Right. Let's try with these z's. All right. So I'll multiply the first z through here. So z times z, what do you guys think that's going to be? Z squared. And z times 6. I got to make sure I have a plus sign there with it. And okay, this one's interesting. This is the first one where I'm giving everyone a negative 2. That minus sign is part of it. Yeah. Negative 2z. Sometimes my 2's and z's look similar, which is why you see I'm putting this little cross line through the z. Negative 2 times 6. Negative 12, yeah. Well, slow down. Let's wait till everyone Everyone gets it. So for combining like terms now, because I want to simplify this and write it in standard form being from highest exponent to lowest. Are there any other z squared friends? I don't. Nope. Just regular old z squared hanging out by itself. And then let's see, 6z minus 2z. How many z's do I have now? 4z. And then the negative 12. If I had some other constants or something, then I could have combined it, but in this case, there weren't any. Okay? So yeah, so that's how that works. Let's see, I'm going to skip example 2. You can read about that yourself if you want to look at that method for multiplying. But when I'm multiplying binomials, there is a common way that people refer to. Distributive property works every time, but if you happen to have binomial times a binomial, you can use what's called the FOIL method. Oh. Let's see, I'll put it up here for you. Aha. And if you haven't, don't you worry. So the FOIL method stands for, it's an acronym, and I want to point out it only works for binomials. Using the distributive property would work if I'm multiplying like a trinomial times a binomial. I could multiply like a 10-termed expression by a 7-termed expression, and distributive property will work. FOIL method works for this very special case, which does happen commonly. It's going to show up often, but this is the shortcut, so to speak. First, outer, inner, last is what FOIL stands for. So the first thing I would do, question? Yeah. I multiply the first term in each of the binomials, and I get x squared. Then I multiply the outer terms, right? The outsides, outermost terms, is so the x times 2, and get 2x. Then I do the inner terms, so that's the kind of the innermost ones. And then I multiply the last terms. And then I just add them all together, which I want to point out is exactly the same thing I was doing when I was double distributing. All right, exactly the same thing. It's just maybe you don't have to draw the arrows. Okay, so let's do some examples with FOIL. Foiled again. Here we go. First, outer, inner, and last. FOIL. So, let's FOIL this. So, take the firsts. No? Yeah, all right, it'll be there. X times x would be my first terms, right? You guys agree? So that's x squared. Actually, let's see. I'll try color coordinating this maybe. X times x is x squared. I don't think the color coordinating is even going to matter. And then the outers, so that's going to be x times 6, negative 6, sorry. So that's negative 6x. And then I would multiply the inners. So that would be the negative 3 in the x. That's negative 3x. And then the lasts. So that's the last term in each of the binomials. So negative 3 times negative 6. I don't know if the colors made it more complicated. Might have. First, outer, inner, last. Right? So firsts, outers, inners, lasts. FOIL. And now I just go through and combine like terms if I can. So let's see, I'd have x squared, negative 9x, and plus 18. Right, so if I just combine those guys, boop, 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 boop. Right, that was negative 9x. All right, let's look at this last one. Oh, this one's a little bit more interesting because I'm multiplying a 2x instead of just an x times an x. Oh, and a 3x. All right, this is a big deal. 2x times 3x. Well, I can multiply the coefficients, so 2 times 3 is 6. And then what's x times x? Yeah, so the outer 2 times 5 is 10, and it's negative, and then there's still an x attached. Mm-hmm. Yeah. Last. So the 1 and the negative 5 are the lasts. Mm-hmm. Yeah. And then let's just combine like terms. So 6x squared, all right. Negative 10x and 3x is negative 7x, and then the minus 5. Right, because I combined those guys. All right, so FOIL, you've probably heard of it, maybe. It works only for binomial times a binomial. And so let's, for our last example, let's consider what if I've got a whole lot of terms and I'm multiplying. Okay? So this one, I'm going to have to go back to distribution. Now, the fact that I've got these two sets of parentheses and nothing written in between them, it is implying multiplication, even though there's not a multiply symbol in between there. I just want to point out that that's what that means. Well, let's see if I can multiply this. So I'm going to take this x and give it to everybody in this other set of parentheses. And there's 3 terms in there this time. So let's see, x times x squared. Uh-oh. What are your guys' thoughts on that? X times x squared. I have to add the exponents. What is that going to be? No? No? Other thoughts, anybody? X times x squared? What's the exponent on this guy? A little invisible 1. X to the first times x to the second is x to the third. All right, there we go. Right, so adding the 1 and the 2. And then let's see, x times negative 3x will be negative 3, and x times x is x squared. And then x times negative 2, negative 2x. And slow down. Wait, x times 5, where? The 5 is in the same family, the same set of parentheses. I'm going to distribute this on the underside because I'm going to run out of space. Let's see, now I've got to give this 5 to everybody in the parentheses. So 5 times x squared, what is that? Yeah, let's see, let's have Austin give us one. What do you think about 5 times negative 3x? You have a guess? 5 times negative 3x. I agree. And then let's see, lastly, let's have Tyler. What is 5 times the negative 2? Think. Negative 10. Yep. And so these problems, for good or for bad, if I made a single mistake on any of these, it then will carry the mistake through the rest of the problem. So that can be kind of annoying. But yeah, you just got to be careful. You know, just be careful. I mean, I could have changed. I could have distributed the 3 terms to the 2 if I wanted it. It actually still would have worked out the same. So yeah, there's a couple ways I could have done that. But let's see. Let's see if I can combine like terms here. Are there any other x cubeds? No. So x cubed. But that's my highest degree, so I'm going to write it first. And then let's see. How about x squared terms? I've got negative 3. I've got positive 5 of them. Positive 2 of them, yep. And when I'm adding, you're just adding the numbers in front, the coefficients. The variables remain unchanged. let's see, negative 2x plus negative 15x, so it's becoming more negative. And then negative 10. I'll draw a house shape for it this time. Negative 10. And there we go. There we go. Let's see. So I think that'll do for now for our internet friends. Have a great day. Thanks for watching. Bye-bye.